and we're going to finish up on the physical property of magnetism today. So, we've already talked about magnets and that they have North Pole and South Pole. They have an invisible thing called a magnetic field. It pretty much looks like this. Now, if it's invisible, how do we know what it looks like? Well, that's our main question. I want you to think about that for a little while I go over the rest of this stuff. And then we'll see if we can't make these invisible magnetic fields visible. Now, the Earth itself, because the core is nickel and iron, the Earth is a gigantic magnet. We have a North Pole and we have a South Pole. We have also a magnetic field that's going around the Earth. We use it all the time. We use it when we're navigating. It used to be, before we had satellites in the air, all the ships would sail around using a compass to show which point is north. If they knew where north was, they were able to find their way. Remember the poles of magnets, north and south. Two norths will repel each other. A north and a south will attract one another. And two souths will repel each other also. Now what does this look like? I have a couple of magnets right here. That's a north and a south coming together. Now, I'm going to turn this one around, let this one stay the same. And now, I have a hard time getting them close together. They don't want to get together. So now, let's turn both of these back around. And it should still repel. And it is. There we go, repelling. Now I can flip this one. And now it attracts. That's the magnetic poles. So, how can you make yourself a compass? Well, that's easy. It's something you can do at home as well. Get yourself a bowl of water, something that floats. Leaf soda bottle cap works really well. I couldn't find one. I cut a piece of cardboard, and what you're going to need is needles. In particular, you just need one. So we learned with the other video that magnetism is caused by electrical charges. Well, when the electrons are lining up, this little piece of steel right here is not magnetic in on itself, but we can make this a temporary magnet. In a magnet, all the electrons are lined up together. What we can do is we can take that force, that magnetic force, and we can rub it here and help all the iron in this needle to align its electrons up. So it can be a temporary magnet. Now it'll lose its magneticism over time. For right now, and you want to rub it on your magnet like this, a permanent magnet. You want to rub it in the same direction. You want to rub it a good 30, 45 seconds. So if you're ever lost in the woods and you need to know your way and your cell phone is dead and you don't have your compass on your cell phone, you can make one. If you're carrying the Boy Scout 10 Essentials, one of them being a sewing kit. All right, now, just going to put this in the water. Drop the needle on top. And checking it with my compass on my phone. Whoops. Just make sure it doesn't touch the sides. And it is pointing north. North is this way, so that's awesome. All right, well, now back to our question. If magnetic fields are invisible, how can we see them? So what we are wanting to see is a visual representation of this. So what I have here is my magnet. I have no idea which is north and which is south, but that doesn't matter. I'm going to put this little card over this, over the magnet. And then, so that I don't get these iron filings all over my magnet because they're impossible to get off, I'm going to put this little piece of parchment paper. Now, I ground up some number 8 framing nails that has high concentration of iron in them. And what I'm going to do is I'm going to drop this on top of here and see if it'll naturally form into the magnetic field and show us what the magnetic field looks like. If you want to do this one at home, this one you can do with adult supervision, and you're going to need goggles because these little iron filings, we talked about this before, these little iron filings are very light and they can blow into your eye, you can breathe them in. I've been working with them for quite some time. I know what to do. All right, so. Stand up, look at me. So I'm going to take a pinch of this. And I'm kind of like the salt mean guy thing here. I'm just going to start dropping it. No. Trying to drop it all over the place and see what we get. I'm gonna go wash my hands before we kind of take a real close look at this. Okay, so again, we're looking for something like this, and I think we got it. Take a look at this magnet. We can tell exactly where the magnet is. But what's neat is not just this, but this out here and this little void. Go ahead and get a little closer shot of that. Bring the light in a little bit. Now here's the phenomenon that I want you to kind of take a look at. As soon as I get my light. There we go. All right, so here's the phenomenon that I want you to hypothesize about, and you can pause the video and make your hypothesis, and then I'll come back and tell you. But look right here, look at this void where there's hardly any particles, but yet there's particles out here. And look how they're all pointing to the magnet. And then the ones on the outside here, they're just dropped. So what's happening with all these little pieces? What's happening with the ones that are close and are pointing? What's happening to the void here? And what's happening to these outside? So if you want to stop and do your hypothesis, you can pause right here. I'm going to continue the video in 3, 2, 1. All right, gave you fair warning. So here's what's happening. So here's our magnet. We can tell where the magnet is. It's pretty easy. It's been underlined. Look at how the filings are pointing. Like this direction out that way, and this way they're pointing directions out this way. Now look at the filings around the outside. Some of them, and I don't know if you can see it on the video, it's kind of hard to, but some of them are actually at an angle like this, and they're pointing towards the magnet, which is very, very cool. But what's happening with this void? Well, these little bits of iron filings, of course, all substances have mass. And this magnetic field has a pull. So all these little ones right here got trapped in that magnetic pull, boom, pulled it all together. The ones on the outside are just far enough that they're not being pulled directly in it, but their electrons and the particles are still being pulled towards it. So while it's out far enough so it's not pulling directly into the magnet, but it's far enough to make them point towards the magnet. This is like an event horizon in a black hole, where you're not being pulled into, but you're still being affected by it, by the gravitational force. Here you're being affected by a magnetic force. Now these that are out here are far enough away from the magnetic field to not be affected much at all. And their mass is so heavy that their mass is keeping them away from this magnetic field is probably out to here, but it's stronger next to the magnet and gets weaker and weaker and weaker as far out as you go. So right here, the magnetic field is too weak to point these in. Over here, the magnetic field is strong enough to point, but not strong enough to pull all the way in. All of these got trapped in that magnetic field where it's the strongest and are sucked in on top of that magnet. All right, so just to kind of wrap it all up here, you can see magnetic fields, but you have to use visible particles in order to see it. Otherwise, we cannot see the magnetic force from this right here. We can't see it. But if I put it under the table, look at that magnetic force. Look at that. You see it? When I put this magnet underneath the table, you see the pull of the particles as I move it across? You can see little bits. You can see the magnetic field when you have particles enough. Otherwise, you don't see it when you just hold it right here. It's an invisible force. So, this experiment you can do at home with parental supervision, because making the iron filings is the hardest part. Basically what I did was grind up nails, and with that I had to use hearing protection and eye protection, even more eye protection than these. With the compass, you can do that. Ask your parents for a sewing needle is all you need, and a magnet, and you don't need a super strong one like I had. You don't need one at all. Remember to do it about 30 to 40 seconds, and you want to take your needle and you want to rub it in the exact same direction, because you want to line up all those electrons so that you can give it a permanent magnetic field like that. All right, so again, if you have any questions, you can dojo me, you can email me, or you can text them to me. So until next time, wash your hands.